Hello and welcome to another video. In this video we're going to be working on minimum number of operations to move all balls to each box. And in this problem you have n boxes and you're given a string boxes of n where boxes I is 0 if it's empty or 1 if it contains a ball. And in one operation you can move one ball from a box to the adjacent box, and adjacent box just means right next to it, and that costs 1. So you want to return an array of answer n where for every index you want to figure out what's the cost of moving every single ball into that index. So like for example for this first problem, in the first box there's only 2 balls. The first one's already in there and the second one's right next to it, so it just takes 1. For the second index this is already in here, so this is 1 as well. And then for this last one, this one takes 1 move and then this one takes 2. And essentially this is how you can do like the brute force. You can basically just say like for the index, where are all the balls and how far are they? So like for this index, for example, this is 2 away, this is 4 away, and this is 5 away. So it would be 2 plus 4 plus 5, which is 11, and so on and so on. And so you can do this like brute force for every index. You can just figure out like, okay, where are all the balls and how far away are they? But there's a better solution essentially, and we can basically do that by figuring out how far balls are away from the left side and the right side, and then we can combine that. So essentially we're going to say for a given index, like let's say we have an array, we can just say like, okay, there's some balls on the left and on the right and we're trying to put them all into here. So how much does it cost to put everything on the left in and then the right in? And then the answer is just those two combined, because all the ball, like if there's a ball in here, that's 0, so it's just the left and the right. And how do we do that with like a problem like this guy? Let's use this as an example. So essentially this is like 0, 0, 1, 0, 1, 1. Get rid of all of these. So what we can do is, like, if we're putting balls in from the left and we're on some box, like this box, there's going to be some cost to put everything from the left into this. And the recurrence relation of putting everything from the left into this, if you want to put them instead into this, it's going to be everything that was to the left of this already is just moved 1 more. And then if there's a ball here as well, that's another 1. So essentially that's kind of like the recurrence relation from one box to the other. It's going to be the same number plus the number of balls that you moved. And then also if there was a ball in that cell, then you move that extra one. And we can just have a couple of variables to keep track of this. So essentially for this, we can have this like original array, and then we can have like a left and a right total array where everything starts out as 0. And then all we have to do is just keep track of the total and the number of balls. You can keep track of like less variables if you want to, but yeah. So essentially total is going to be like the total cost to move everything in. And then the number of balls is how many balls we have. So total is going to start out with 0 and balls is going to start out with 0. So we'll just do how to calculate the left, and then the right is basically the exact same thing, just in reverse. So let's say this is our original array. So we're going to calculate how much it costs to take every ball from the left and put it into our cell. So in this first thing, there's nothing to the left, so this is just 0 because there's nothing to the left. Then we check, is there a ball in the cell? There is no ball in the cell, so we don't need to do anything. Then for the second one, there are no balls, so we're just done. And is there a ball in the cell? No. And then here, there are no balls to the left as well, so we're just done. But there is a ball in here now. So we're going to say we have 1 ball now with a total of 0 still. Then when we go here, because there actually is a ball, the number to put all the balls to the left into this guy is the same as this guy plus the number of balls, right? Because every ball you have to move it 1 more. So essentially we're just going to add total plus the number of balls. So the total will now be 1. And here we're going to put in 1. And there is no ball in here, so we don't need to add it to the number of balls. Then over here, we do the same thing. We say what was the previous total, and we're going to add the previous number of balls. So this is just going to be 2. Put in 2. And there is a ball in here, so we're going to add that in. And for the last one, actually, we're just going to do the same thing. We're going to say what was the previous total, and we're going to add the previous number of balls, because if there were 2 balls to put into here, they need to move 1 more cell each. So it's just going to be 2 plus 2, so 4. So we're going to put in a 4 here. And then there is a ball in here, so now we have 3 balls. So this is basically the left array for this. The right array is the exact same thing, just in reverse. And once you have a left and a right array, the answer will just be left at the index plus right at the index, right? Because we basically broke it down to how much does it take to put every ball from the left in and how much does it take to put every ball from the right in. And that's going to be the answer. And we can actually do this in O1 space by putting every ball from either side into the result, calculate the other one on the fly and the result on the fly. So that's what we're going to do. So that's going to be like the optimal. Okay, so yeah. So let's just say, let's calculate the one from the right on the fly or ahead of time, and then we'll calculate the left as we go, and then put it into the result and only use the result array. Okay, so we're gonna have this length of the boxes, and then we're gonna make a result array, which is just gonna be length of this boxes thing. So say do it in Go. And we need these two variables, right? The number of balls and the total, which is gonna be 0 and 0. Okay, so we're gonna pre-compute the right side. So -1. Okay, so this is just going to be, we're going to store this in this result. So originally the result is going to hold this right total essentially. So we can just say result I equals total. And then we're going to add to the total, and we're also, so actually, no, first thing we need to do is we need to, forgot one more thing. So first thing we need to do, remember, is if we have balls, we need to increment total. So we can do that here. Then we're going to make this. Now we need to check if there's a ball in here. So we can basically just say balls plus equals, convert the string to an int, and subtract this. And this is also essentially what this will do is, if this is 1, 1 minus 0 will be 1, and 0 minus 0 will be 0. And you need to have an offset because the ASCII value for 1 and 0 isn't like 1 and 0, it's like 50 or whatever. So this will make it 1 or 0. So if there's a 1, we'll add 1. If not, we'll just add nothing. Okay, now we need to reset the balls in the total and do the exact same thing left to right while maintaining a variable for this left. I guess the variable for the left will be the total now. So we'll just use the total to compute, and then yeah. So now this is just the opposite. So 0 is less than b and plus. Okay, so same exact thing. So total plus equals balls. Now this is not going to be total. This is going to be total, or actually we can just do this. So we can take, we already have the right value in here. So we can just, the total is going to be the left side now. So it's going to have the right already. We'll add the left, and then we'll do this as well. And I think that should be it. So let's see. And there's a bunch of these problems like calculate, you know, like product of all numbers excluding this number. All these problems have this pattern where you get a left array, get a right array, and get a total. And if you want to do it in Nov1, this is how you do it. You store the left array in the result. You compute one of them on the fly. You can't compute both on the fly, so you store one in the result, you compute one on the fly, and then you just put it in directly. All right, let's see what we get here. Okay. Okay, there we go. So it should be a 1. It says O of n, but yeah, I mean, basically we're just using the result, so. Yeah. So this is going to be n runtime, because essentially we have 2 loops, and this is a 1. Yeah, so hopefully this is helpful, and the main thing to look for in these types of problems is figure out like how to move things around, what's the optimal way to do it, know that, I mean, I guess technically here you can do this in n squared, so you can actually just, for every index, figure out where all the balls are, but you just want to find this like pattern of like, okay, if I move from one index to another, what changes, what's the minimal amount of thing that changes, and basically the minimal amount of thing that changes is every ball on one side just needs to go one more, and then if there was a ball, you just need to add that. So hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.